Hello students, now we are going to study how the motion of a charged particle get affected when it is moving in a uniform electric field. Here we can see the diagram. Here this is the uniform electric field E represented along y-axis from positive to negative end. This is a plate PQ where if we keep the charged particle inside the electric field, or if the charged particle is moving, it will move toward this direction and it will strike at any point on the screen. So we can study its motion. Right, let x is the distance for which the electric field existing, and after that there is no effect of electric field. Now let us consider a unit positive charge plus q of mass m moving with velocity v enters the uniform electric field along OX direction. Now suppose first case that there is no uniform field existing, electric field existing in that region. In that case, as the charged particle will enter at this point plus q, it will move straight and strike the screen at point A as is represented by here, since there is no effect of electric field. But if some electric field is existing here, in that case the charged particle q, which is entered with velocity v, since the charged particle is plus q, so it will move toward the negative terminal of the electric field, negative end of the electric field applied. So it will move upward. Why? It will be due to the force experienced by the charged particle due to electric field, which is given by F is equal to QE. Since the force is being experienced by the charged particle, so it will be having some acceleration A given by F upon m. So we can put the value QE by m. Right? So this is the acceleration which is experienced by the charged particle when it enters the uniform electric field. Now one point is to keep in understand that since the particle is moving along OX direction and acceleration is acting to perpendicular to the direction of the motion, so the speed of the charged particle will not change. Speed will not change. Only what change? The change will be only in its paths of motion. Right? In case if the charged particle is entering in the direction of uniform electric field, like along OY direction, then there will be the acceleration of the charged particle, and in that case the body's speed, the particle speed will increase. Right? And we can say the motion of the charged particle will be accelerated. And if the charged particle is entering in a direction opposite to the electric field, again in that case also there will be acceleration, but in negative direction, which is known as retardation. So in that case retardation will occur. Retardation will occur. So these are the three cases, that if the charged particle is at rest, or is moving along the direction of electric field, or is moving opposite to the direction of electric field, then only the speed will change. Otherwise, if the charged particle is entering in a direction perpendicular to the direction of electric field, there will be no change in speed. Only the path, or we can say the shape of the path, will change. Now let us discuss how. Now let us consider the charged particle q is entering in this direction, and for time t, the time can be calculated as, since the velocity is v, and we know that velocity is equal to displacement upon time. So from here we can find out t is equal to x by v. Now let us consider in this uniform electric field, the charged particle, since it is get attracted toward this end, so it will follow the path like this, and this is the displacement y in the vertical direction, and as it leaves the electric field, it will move straight along the tangent to this path. Right? So let us find out this y value. So in that case, y is equal to, using the formula, is equal to ut plus half at square. So s is y here. Y is equal to 0 plus 1 by 2. A we have just calculated, QE by m into t square. So we get the value y is equal to 1 by 2 t, we can put the value t from here, this is t, x by v, 1 by 2 QE by m into x square by v square. So all these are constants, so we can write y is equal to kx square, which is the equation of parabola. It means whenever the charged particle is entering in a uniform electric field, it will follow a parabolic path, and when it leaves the electric field, it follow the straight line path as equal to the tangent to the parabolic path.